Okay. M1, I told you it's most of the logic or the concepts of physics are coming in from the IGCSE. From the IGCSE. There is nothing coming in from the A level physics. Everything that you've done in your physics in IGCSE, those things are then the questions are more a little bit complicated. They are longer questions. They give you a complete situation where you have to understand, analyze what is happening, and then you accordingly do the relevant work and get the solution and get deduce things as well. You can give a conclusion to the solution as well. So the most important part of this forces chapter is of this M1 is understanding forces first of all. Understanding vectors. First of all, vector is a quantity which has three things, which has a direction, which has magnitude, and which has a unit. For example, force. Force is a vector quantity. Displacement is a vector quantity. And velocity is a vector quantity. Pressure is not a vector quantity because pressure, there is no direction associated with it. For example, length also, a simple length is also not a vector quantity. And temperature is also not a vector quantity because it does not have any direction. You only work with the magnitude in the units. When you have vectors, then how to resolve vectors? When you have two or three vectors interacting with each other, resolution of vectors. This is also important. Resolution of vectors. So whatever the vector quantity is for that particular situation, if it is displacement, if it is force or velocity, you can find the resultant vector. You resolve the vectors and you find the overall effect of the vector, overall vector. Find the resultant vector because eventually the effect that is produced on a certain body is because of the resultant, the result of all of the vectors that is acting. For example, if there's a car that you are pushing, I am pushing, Arham is also pushing, the overall force because of our three separate forces, when you add them up, the overall force will cause the car to move, not the single individual ones. So the three forces which we are putting on the car, they add up, we resolve it, and then eventually the resultant force of the three forces, it causes the car to move. So you'll have to resolve the vectors first, and then you do the secondary part, the whatever that happens in it, motion and everything. Now any vector is represented by arrow. By arrow. And this gives you the direction and the length of the arrow. This gives you the magnitude. This represents, you can say, the magnitude. Magnitude means the size, how big the vector is, the size of the vector. For example, a force of 10 Newton and the force of 5 Newton. So the force of 10 Newton would be longer. The vector of the 10 Newton force would be longer. The vector of the 5 Newton force or the 1 Newton force would be smaller. So the size is denoted by the length of the vector. And then you have opposite vectors as well. Opposite vectors, for example, if this vector it is 5 Newton positive to the right side, this would be exactly same. You can see the length is exactly same. This would be the direction is opposite. It will be negative 5 Newton. Oh, sorry, 5 Newton. Similarly, this if this is upwards 10 Newton, so this would be downward 10. So if the forces are exactly opposite to each other, so the amplitude is look the same, but because the direction is exactly opposite, what happens? That you will now put the minus sign because direction is opposite. And whenever because I told you direction is important, so because of the direction, we have to have there's a need for a standard directions. What do you say? Standardized directions. So if we go to the right side, we take it positive. If we go to the left side, if your arrow is to the left side, we take it negative. If it is upside, we take it positive. If it is downside, we take it negative. So regardless of the whatever the value is, if your vector direction is to the right side, we would take it as a positive vector. We would write a positive 10 or positive 15 or positive anything. If it is going to the left side, then we write it as negative 15 or anything. And then it is very simple sometimes to resolve forces which are anti-parallel. These are anti-parallel forces. Anti-parallel, do you know what is anti-parallel?
Like, no, not really.
Parallel means that they will never meet. Right? They are parallel to each other, they will never meet. This is going to
Yeah.
the right side is going to the left side. And anti-parallel means that the direction is opposite. This is going on the right side, this is going to the left side. And they will, even if you extend these two infinite for infinite length, they will never meet each other. So they are parallel and they are anti-parallel because of the direction, opposite direction. One is going to the left, the other is going to the right. This is going up, this is going down. They are parallel and they have the opposite direction. Anti-parallel.
Got it. Got it. Thank you.
And if the vectors are in the same direction, it's very simple. If they ask you to
Just
resolve
parallel.
the you will simply add them. If there is
Yeah.
5 Newton over here and 2 Newton in the same direction, the overall effect would be, the resultant force would be 7 Newton. Positive. Similarly, if you have this is 15 Newton, this is 1 Newton, and this is 7 Newton. Now, what would be the resultant force in this case?
So that's 16 on, no, yeah, that's 16 going to the left, 7 going over there. So 9 newtons going to the left side.
Yes, you can either write 9
Negative
Newton.
9 or negative 9, yeah.
Yes, you can either write 9 Newton left to the left, or you can simply write
negative.
minus 9 Newton. The minus will now denote that the direction of the force is negative, which is the left side.
Yep.
Now, whenever you write down the resultant force, this is one of the ways. And the final answer that you give for the final answer that you would write 9 Newton to the left. You give the magnitude in the final answer and you give the direction.
Direction.
Both are important. You don't just write down the magnitude. You would say that it is 9 Newton to the left side or the negative x-axis. You can also say negative x-axis because it is again left side. It goes left side. Okay. But what if they are not parallel? The forces are acting at an angle to each other. For example, when forces are acting at an angle to each other. For example, this force is 30 degrees, 10 Newton, and this force is 40 degrees, 7 Newton. They ask you to find the resultant force. How would you do that, do you know?
Wait. I'm pretty sure, like, yeah, we did this, but like, you're supposed to separate the vertical and like the horizontal
Yes,
components and
you
stuff,
break it
right?
down into vertical
Yeah.
and horizontal components. You break down each of the
Yeah.
force into vertical and horizontal components.
Vertical and horizontal. I'm just trying to think, how would you do it after that? Oh, never mind. I didn't remember. Okay. I got it.
How to break down?
You use SOHCAHTOA. So for the vertical. For the right triangle, it will be sine of 30. So it will be 10. Wait, sorry. It will be sine 30
This
equals
is your
to
10 Newton force.
so x. Sorry.
Yes, yes.
So that's just sine 30. It's just 10 sine 30.
10 sine 30 is what? The horizontal or the vertical?
The vertical component is 10 sine 30, and then the horizontal
What with the direction of the vertical? Like this or like this?
Down.
Down.
Wait, no, it's going up, right? So it'll be going up. Sorry, my bad. I'm just
You will
doing it in my
down
mind.
into
Okay.
horizontal component. This would be the one, and this would be the one.
Yeah.
You know about what was the name of it? Head head to tail rule.
Yeah, tip to tail.
Yes, tip to tail rule.
Yes.
So this
Yeah.
is the result that you are trying to work out.
It's 10 sine.
Then
Yeah.
you are breaking down this resultant force into the x and the y components. So the two components, it starts from the tip of the resultant force, and the last component would end at the head. The head of the last component would end at the head of the resultant component. So now you would use simple Sukatoa, and you will get the components. So the vertical component, vertical
10 sine 30.
component, it is always the sine of the force into sine theta. Vertical component, or you can say the component which is opposite to the angle. Okay. Vertical component, or you can say the better thing is to write component opposite to the angle will always be f sine theta. And similarly, component which is adjacent to the angle will be f cos theta. So you can see this side is adjacent to the force, sorry, to the angle, 30 angle. And this side is opposite to the 30 angle. So this means now that the vertical force over here in this case is FV. Vertical force, it is 10 sine 30. And FH, horizontal component, will be 10 cos 30.
Yes.
And then you can use your calculator. This is how you will break
Yeah.
down. So over here, whatever the formula, whatever the diagram is that you have, you will make the vector diagram. You will break down all of the components in their vertical and horizontal component if they are not vertical and horizontal. If the components are, if the force is already vertical and horizontal, you don't need to break it down. So you will break down. This is the region. So this would become, we just found it 10 cos 30, and this would be 10 sine 30. And similarly, this force would be, and this would be the vertical component for the 7 Newton force, and this is adjacent to the angle. So this would be 7 cos 40. And this is opposite to the angle, 40 and opposite to the 40 degrees. So this would
Yeah,
be
7 sine
7
40.
sine 40. So then what do you do? You want to find the resultant force. So resultant force is what? The sum of forces. So resultant force in the x direction and resultant force in the y direction, or vertical or horizontal resultant forces. Resultant force in the, yes, you can say vertical and horizontal and vertical. So you would now put the signs with each of the components that you have broken it down into. So you have 10 sine 30, sorry, cos 30, 10 cos 30, which is moving to the right side. So this is positive. Then you have 7 cos 40, which is going to the left side. So this will be negative 7 cos 40. Then you have vertical forces, both are upwards. So both would be positive. 10 sine 30 plus 7 sine 40. You will use your calculator. You will get the Solutions.
Yeah.
So 10 cos 30 minus 7 sin 40. Sorry, cos 40. 3.2979.
I just made it 3.3.
9.499. Now the overall resultant force with the direction and everything. So if you draw these resultant forces of the horizontal and vertical component, you will get a diagram something like this. The horizontal component is a positive one with 3.2979. And the vertical component is again a positive one, so it will be going upwards, 9.499. And the resultant force will be this one. This is the resultant.
Yeah, so in order to
Overall
find the
resultant force
magnitude,
will be equal to, now
result,
you will use the what is the name of the Pythagoras theorem?
Pythagoras.
Resultant force is horizontal square plus resultant force is vertical square and square root. So square root 9.4995 square plus 3.2979 square. So 10.06 something Newton.
Yeah, 10.
This is the overall resultant force. And now you would also need the angle, the direction. The direction you can use Sukatua or you can use 10.
This 10, yeah.
10 inverse of the resultant force vertical upon the resultant force horizontal. This will always give you the angle. So in this case, this would be 10 inverse of vertical 9.499 divided by 3.2979. So this is 70.85 degrees. And you can see this is with the positive x-axis. Isn't it? This was the x and y-axis. And you can see this was the x-axis. And this is how much the angle is anti-clockwise, 70.85 degrees from the positive x-axis. Okay, this would be a final answer.
Yeah.
The right resultant force is, yes.
So also, if I wanted to write it as a bearing, I would minus it by 90, right?
Yes. If you want to write as a bearing, that is your convention. Whatever the reference point that you want to take, the answer you have to reach the same position. If you use the bearings or if you use the x-axis as your reference, you will get the same answer.
Yeah. I
So this
understand.
70.85 degrees anti-clockwise from positive x-axis. No space. This is the final answer.
Yes, I got that. Okay, nice.
There are two cases in this one. First one is when they ask you to find the resultant force, and sometimes they give you that the object is in equilibrium, and then find the unknown. Okay, so in this one, the main, if you understand how to break it down properly, then the half of your part is already done. This would be the vertical and horizontal component for the 25 Newton one, and this would be the vertical for the 18 Newton. This would be the horizontal for the 18 Newton. Now, if you break it down, the horizontal component, this one, what would this become?
Horizontal, that would become.
Would this be the sine for the?
That will be sine 18 sine 10.
No. I told you. The component which is opposite to the angle, that is sine.
Wait,
And
sorry,
the
which one are you
component which
talking
is
about?
adjacent to the angle,
Yes.
this one,
So
this one.
the Oh, sorry. I thought you're talking about the 18 Newton one. So for that one, that one that is 25 cos 15, and then the vertical is 25 sine 15.
Yes. And then over here as well, this
That is
would this be
25
vertical? This is
18
vertical.
18 cos. Yeah, that's 18 cos 10.
It,
Yeah,
it doesn't matter if it is vertical or horizontal. It depends on the angle. If it is
exactly.
with the component, then that component would be cos, and this one would be 18 sine 10.
Yeah, exactly.
And then now you will find sum of fx. You can also write it like this: sum of fx. This means summation.
Summation, and fx is like the resultant forces.
Sum of fx. There are two forces in the x. One of sine 10, and then you sum the y component. So this would be vertically upwards. You have two components: 18 cos 10 plus 25 sine 15, and the 17 Newton is negative, so minus 70. Okay, and then you would use a calculator. 21.02 Newton, and this one would be 18 cos 10 plus 25 sine 15 minus 70, 7.19. So again, both the x and the y both are positive. Both are positive. The resultant force would also be in the same direction. The resultant force will be equal to the square root of the sum of x is sum of y is 21.02 square plus 7.197 square. So 22.2, 22.22. And the angle, which would be this one, theta. This would be equal to tan inverse of vertical divided by horizontal. Tan inverse of vertical is 7.197 divided by horizontal 21.02. So 18.9 degrees. So this is your answer.
Yes, sir, I understand. Got it.
So you always break down your forces into components, then you work accordingly. You can copy it down, take a screenshot, and then we'll move on to the next one. When they talk about equilibrium. Equilibrium. Equilibrium in terms of physics, there are two types of equilibrium. You have a static equilibrium, you have dynamic equilibrium. But the thing that is common to both of them is that the resultant force, overall resultant force is zero. Overall
Right.
resultant force, the sum of all of the forces acting on that body will be equal to zero. So sometimes they would give that a situation that a body is in equilibrium and there are some certain forces acting on it, and they would give you an unknown force or an unknown angle to find. For example, if you have this angle f Newton and degree theta, we don't know. There's another force over here which is 3 Newton at an angle of 10. 10 degrees. And the horizontally down force, which is 2 Newton. Now this will ask you to find the unknown. Thing is, we know because this is in okay. It is in it because if it is in equilibrium, we know the resultant force would be equal to 0. And if resultant force is 0, this means that the sum of vertical forces will be also equal to 0 and sum of horizontal forces would also be equal to 0. That's why square root of 0 square plus 0 square will get you the answer 0. So now what? In this case, you would again break it down into components. So this would be the horizontal component. This would be vertical component for this one, horizontal component and vertical component. And then if you write them down, this would be f cos theta. This would be f sin theta. And this would be 3 cos 10. This would be 3 sin 10. And now if you find the, okay, one more thing. We know that the sum of the horizontal forces would be equal to 0 and the sum of the vertical forces would be equal to 0. If this is the case, then we can also say that in the case of horizontal forces, the left side forces would be equal to the right side forces. And the upside force would be equal to the downward force. Because if both are equal up and down, then the overall would become 0. If the left and right, if they're equal, then again, the overall would become 0. Do you get it? So now if
Yeah,
we
I
know about
guess,
this,
yeah.
so now the left side forces, there are two forces, left and right. So there is no need for the positive negative sign over here because you are just equating the left side with the right side. So you will get one equation for the horizontal one. You will get f cos theta is equals to 3 cos 10. The force on the right side, this one would be equal to the force on the left side, this one. So it's such that they both will cancel each other out. Overall would become 0. Similarly, vertically, this would be f sin theta plus you have another vertical force 3 sin 10 equals to downward force, which is 2. So you form these two equations and now you will solve them simultaneously. So for the first one, you can't do anything more to that. For the second one, you can do f sin theta is equals to 2 minus 3 sin 10. And now if you divide both equations to solve it simultaneously, there is one way that you divide both equations by each other. So this would be this and this would be this. So you will get the f and the f would cancel out. So you will get cos over sine equals to 3 cos 10 upon 2 minus 3 cos 10 upon 2 minus 3 sin 10. So this is coming out as 1.9975. And if you do the reciprocal on both sides, this would become sine over cos, which would be equal to this answer 1 divided by this answer. 0.50062. So sine over cos, we know it is 10. So tan theta is 0.50062. And so the value of theta would come out as tan inverse of this answer, which is coming out as 0.5005. Tan inverse 0.500624. 26.593 degrees. And now you want to find the value of f. So you can choose any one of the equations. F cos theta is equal to 3 cos 10. So f will be equal to 3 cos 10 divided by cos theta. And theta we now know 26.593. So 3 cos 10 divided by cos 26.593. So 3.303. So these are the unknowns that they asked us to find. And we found these because they told us that the situation was in equilibrium. The body at the center at this point was in equilibrium. And then that's why you form this equation, then simplify it, simultaneously solve them, and you got the values of the unknown. Any questions in this one? It's okay. It's just math, basic math, science. This is one another way of solving simultaneously. You can do it other ways as well. You can do it. You can make f subject and then substitute the f in the other equation. Eventually, you will get to the same answer.
Mm.
This is something that you can try. This is also another way
Right.
of solving simultaneously. Okay.